In this video, I'm going to walk you through Lesson 5 of Unit B1. Okay, so first of all, we ended Lesson 4 by creating a consensus model, and we're talking about food, which is the grass that wildebeest eat as they migrate. And so we decide in this lesson that we might use a model to help us kind of simulate what's happening when the wildebeest migrate. And so we're going to start by mapping the model. And so here is a mapping tool. This is the answer key. And you can see that we're going to actually use a kinesthetic model. So students are going to act out the wildebeest eating grass. And so you're going to have students with hands on their heads like horns. They will be the wildebeest. And then the person holding their hands like this in front of them, they will represent the grass that grows in the Serengeti. Time will be represented as in years. And so each year that passes will have new rounds that happen of the model. And then we're going to actually only be looking at grass because this is probably the biggest factor that we're looking at that might relate to migration, or that's what we think right now. And so we map this kinesthetic model that we're about to create or act out. And then we enact the kinesthetic model. And so here is a directions. This can be found in the teacher guide, and you can see that you're basically going to set up the two sides of your room. One side will be the grass, the other side will be the wildebeest. You could do this in an outdoor area, in a hallway, anything that will work better than your room if you do not have enough room in your classroom. And so you're going to start with 2 wildebeest, and the rest of the class will be grass except for 2 observers. And your observers will record the data on like a poster chart paper or a whiteboard or whatever you have to, maybe a clipboard and a paper, whatever they have to record their numbers. And so you're going to start with 2 wildebeest. And then when the first round begins, you're going to have the wildebeest go over and grab a person that is representing the grass, and then they're going to bring them back to their side. And so you're going to, because only 1 wildebeest can give birth, and it takes a pair of wildebeest, we're going to say that for every 2 wildebeest that survive, 1 offspring will be included in the next round. And so you can just add up the number of wildebeest and multiply by 0.5 or half of that. And all of this will be on the data table that's in the handout. And let me show that to you next. And so this will be several different rounds. They say about 10 to 15 rounds will start to show the pattern. So this is the handout. I'm going to actually open the answer key, and you will see the number, the years will be recorded here. That's the number of rounds. Starting wildebeest, you're going to start with 2. Obviously, 2 are each going to grab grass, and so then they'll have 1 offspring, and so the next round's going to have 3. And then you're going to have 3 people grab the grass, and then you will have another 1 added because you need 2 to reproduce, and so the next number will be 4. So you can see how this works. So this should be very similar to your classroom data. However, it kind of depends on how many kids are in your class, whether it will go into these higher numbers right here. Then they're going to graph the data, and I'll show you this next, the slides that go with this. But you can see that we're going to have a lot of resource availability, so it's going to go up exponentially until we get to this carrying capacity, and then it goes up and down, and we're absolutely developing the term carrying capacity by the end of this lesson. There's also some questions that they're going to answer. And so one thing I will point out in a moment is that you're going to develop the term algorithm, and students are going to express basically what our data is showing in words. And I will say, here's different examples that students can use, but I will say this is the one that you really want to move towards. And that is that an algorithm is an if-then statement. And I'll talk more about this in a moment. But if the wildebeest population increases, then the grass will decrease. If the grass decreases, then the wildebeest population will decrease. So it's if-then statements, and see if students can kind of look at those relationships between increase, decrease, or stay the same. If the wildebeest population stays the same, then the grass will stay the same. And so this is a nice scaffold to get students to understand what an algorithm is. Okay, so we developed this algorithm, and here is the slide that goes with it. And it says, if the number of wildebeest is less than the number of grass, then all the wildebeest will survive. So the slide also does that if-then statement. This is really what is most important, I think, for students to get out of what an algorithm is. And one word, or one way that students have probably already heard this term before, is through social media. And so algorithms will determine what you see in your feed. And so you can say, if you click on cute puppy dogs, then you're going to get more cute puppy dogs in your feed. And so that's one very relevant if-then statement you can use. And they've heard that word algorithm before. So it's a mathematical statement that can help explain the data or what's happening. Okay. And so then we reflect on using the kinesthetic model, and we're just basically going to be talking about like the limitations of the model. And where we're getting to with this is that we're only looking at one limiting factor. We haven't looked at anything else that could limit the population of wildebeest. And so we then read an article or look at some data, and it's called Wildebeest Data Handout. I'm going to open the answer key, but what we're going to notice is that there's two variables on here that we have not really looked at yet that could kill off the wildebeest, and that would be drought and disease. So let me go ahead and open the answer key. Now, there's a lot of questions that students are going to answer with this, and that would be talking about the historical data, but most importantly, it's this average rate of change. And so there's a few suggestions in the teacher guide of how to do this, but notice they're going to calculate it for this time period between 1961 and 71. They have these numbers here, and I found it very hard to get these numbers from the graph that was provided. So I'm going to suggest you model this one with students, and you do it together as a class. You're showing how to calculate the rate of change. And then I would give these numbers on the board for the people that are going to, maybe you can divide the class. Half can calculate this one, half can calculate this one, or everybody in small groups calculates the both, but give these numbers to students, because I'm not sure how they're supposed to get them from the graph. Maybe I'm missing something, but I'm not seeing these numbers on the graph. So I would give them to them and have them practice what you modeled as a class using these numbers. Okay, so then we're going to co-construct the population rates of change. That's what I just explained to you. There is a slide that supports it. You find the difference between the X values and the Y values. So there's a slide to walk you through it. But again, I would give them the numbers, do the first one as a class together. And then you're going to discuss the relationship between the wildebeest population and grass and carrying capacity. And this is a building understandings discussion. This will be the graph that's on the slide as you facilitate the building understandings discussion. There's also some key questions that'll be in a slide to support you. What happened with the wildebeest population during the time span you analyze using the rates of change? So you're going to use what's in the handout and take it to the discussion. Scientist circles, I really do suggest using these. You just have them stand around the perimeter of your room. Standing, I think, kind of increases engagement and also helps you, if it's in a circle, kind of go in order to see who has participated. That's in the beginning of facilitating these types of discussions to get everyone to participate, kind of go around the room. Eventually it could be more like popcorn, and one says something and then somebody else responds. I do know some teachers that actually keep track of who has participated, and some even put participation points, not a big value, but in the grade book. to make sure everybody's participating. But again, when students are first getting used to this curriculum, I suggest just kind of going around in a circle and having everybody or every partnership or small group share something that they came up with on their handout. There is some key ideas in the teacher guide. And these key ideas are really important that you need to help pull out of the discussion. And that is really to understand the idea that a population can reach a certain number before the population decreases and then fluctuates around that point. And we're going to call that carrying capacity. And it is going to go up and down slightly around that carrying capacity. So that's the big idea here, is that we have developed the term carrying capacity. We then add it to our personal glossaries. This is the definition that's provided in the teacher guide. Whatever you co-construct with the class is fine. And they write this probably in a section in their notebook. And then we're going to update our progress trackers. There is an answer key here. I would be very intentional about when you do the progress trackers, because if you just did the building understandings discussion, the progress tracker can seem kind of repetitive or redundant. Sometimes you might want to do the progress tracker at the start of the next lesson to kind of refresh our memories of what we did and kind of look back and say and have them reflect and add to their progress trackers. These can be kind of hard to do right one after the other, the building understandings discussion and then the progress tracker. But if you have time, it's a good time filler as well. So you're going to complete the progress trackers, and then there's an exit ticket. Oh, before that, they're going to look at their conservation profile organizers from lesson 1 and kind of reflect on the questions that they can now answer. I'm going to say that could be cut. You can just probably have a quick discussion. It's up to you. It's really about timing at this point, right? And then there's an exit ticket. Again, you can push this to the beginning of the next lesson if you want, but this is going to collect student responses in a Google form. You will need to make a copy of this Google form so you own it and the responses go to your Google Drive. But this exit ticket can kind of tell you if they figured out what carrying capacity is. And you can always add questions and make it a little longer if you want, or modify if needed. So that's it for lesson 5. Let's talk about materials prep next.